All right, let's take a look at our lesson today on the unit circle. So perhaps the word unit is familiar to you. It really means the unit of one. And as we look at this circle, this is the unit circle, we see the radius is 1. That's why it's called the unit circle. And so if we wanted to write the equation of the unit circle, it would be x squared plus y squared equals 1. We're really not going to need the equation, in this unit, but that just would be the equation of that circle. Okay, so let's talk about the unit circle and how things are oriented. So as you see from this original, this one I'm showing you, this distance along the x-axis would be considered the x-coordinate. It's listed right here. And the distance from, the x-axis up to this point would be the y-coordinate. So that's the coordinate points along the unit circle are x and y coordinate points. The angle measure is measured from the x-axis. You can see this arrow, and we rotate the positive way. If we have a positive angle, we're going to rotate counterclockwise, and so our theta would be measured from the x-axis rotating counterclockwise if we're positive. All right, so what is the unit circle? What's the big deal with it? The unit circle is the points that we're going to be looking at are created by special right triangles, either the 30, 60, 90 or the 45, 45, 90. And so those are the special coordinate points that we will be dealing with for the most part. As you can see, the 30, 60, 90, and you don't have to memorize this triangle the way that it's written, but it's just kind of just as a demonstration. What does that mean? If this radius is 1, which it is because it's a unit circle, then, and this is 30 degrees and this is 60 degrees, then you would calculate using the special properties of 30, 60, 90 right triangles, these side measures. Okay, and as same thing for 45, 45, 90. With a radius of 1, and in this case the hypotenuse 1, we would calculate our side measures and get root 2 over 2. Okay, so what else about the unit circle? Let's actually look at a filled out unit circle. Let's kind of talk about it and study it for just a moment. Notice that the cosine is in the x-coordinate spot and sine is in the y-coordinate spot. Okay, that's very significant. What that means is that we relate the x value with cosine and the y value with sine. Okay, so that's pretty important. And so as we go around the unit circle, we see that we're starting here at 0 degrees or 0 radians. I'm going to talk about radians in just a moment. As we rotate counterclockwise, you see we're pretty familiar with degrees. So we see the 30 degree, the 45 degree, 60 degree, 90 degree, and it just keeps rotating around for all of our special angle measures created by the special, right triangles. So we're going on a positive rotation, going counterclockwise. So let's focus a little bit on radians. This may be the first time you have ever heard of a radian before. And in talking about it, let's talk about the circumference of a circle. We know the circumference, the formula for circumference of a circle, right? It's pi d. D is diameter. So if the radius is 1, what would the diameter be? Yep, the diameter would be 2. So the circumference of the unit circle is 2 pi. We can relate this to radians. As you see, as we're traveling around the circle, we start out at 0 pi, and we go all the way around. We hit pi right here, keep going, and we get back to 2 pi. So there is a relationship between the circumference of the unit circle and radians. Radians, though, are another way to measure an angle. Radians are an angle measure. Radians are an angle measure. and they're the, actually, okay, I think they're the perfect angle measure. They don't have, there's no units associated with them. There are no units. Notice how on the degrees, we have this little degree symbol. That's, you know, it's 30 degrees. We don't have a, like a unit symbol on pi over 6 because it has no units. So let's kind of focus on, let me highlight all of our radian measures. These are measures that you will need to be comfortable with. I know it's so exciting. You're going to use them in Algebra 2 and Pre-Cal and Calculus. They're just, you know, they're not going away throughout your next few math courses. And so those are radian measures. So what I'd like to do is just walk us through, you know, what does it mean? So we're just doing an overview right now. If I were to ask you, what is cosine of 30 degrees, what would you tell me? Okay, so we would go to our 30 degrees and we say cosine is related to x. So we see the x coordinate at 30 degrees is root 3 over 2. So cosine of 30 degrees would be root 3 over 2. That's where we're going. That's how we're going to, in this first lesson, we're just going to use this unit circle and we're going to read things off of the unit circle. But at some point, you will have this memorized. And you're like, what? Memorized? Let me just kind of start out. Let's start out by talking about radians. Let's go to this. And let's just ignore, we're going to ignore this stuff right here. We're not really, I'm just using this, you know, I'm just using this as a circle. We're just going to use it as a circle. This is an example. So the radian measure tends to be what confuses students the most. How do they know all the radian measures? And what I would tell you is the easiest way, or this, well, this is my easiest way. The easiest way that I have done them is by counting. The 30, 60, 90 angles are all pi over 6. They're multiples of pi over 6. And the 45, 45, 90 angles are all multiplies of pi over 4. So to get the angle measures, let's just start this. Okay. So this, the red ones or pink ones, whatever color you're seeing, these are the 30, 60, 90s. So this first one would be 1 pi over 6. This would be 2 pi over 6. 3 pi over 6. We do count the quadrantals. These, the x and y axis, are called the quadrantals. We do count that every time. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. Then we're just going to go around and reduce. You know, we can't leave our fractions in non-reduced form. So pi over 6, that's good. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6 can't reduce. 6 pi over 6 is pi. 7 pi over 6 can't reduce. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And 11 pi over 6. And then we have, this would be 12 pi over 6 or 2 pi. All right, so that's how I figure out where, you know, if I want to know where 7 pi over 6 is, I just count around. Now we count the 30, 60, 90s separately. So let's count the, the 45, 45, 90s and the 30, 60, 90s. We count them separately. So the blue ones are the 45 degrees. So we would start out with 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, let me erase this out of here, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, going through and reducing. Let's see, 2 pi over 4 is pi over 2. 3 pi over 4 is already reduced. 4 pi over 4 is pi. 5 pi over 4 is reduced. 6 pi over 4 is 3 pi over 2. 7 pi over 4 is reduced. 8 pi over 4 is 2 pi. So that's the little, I guess you could, it's not really a trick, it's just how I remember all of the radian measures, which you would, you need to become comfortable with. Because in pre-cal, we're going to pre-cal next year, pre-cal we use predominantly radian measures. Okay? So let's look at what we're going to be doing with these radians and degrees. We're going to learn how to convert them. If we are going from radians to degrees, we're going to multiply by 180 over pi. Okay, let's look at another scenario. If we're going from degrees to radians, we're going to multiply by pi over 180. So you just have to remember, is it multiplying by 180 over pi or pi over 180? So how would we figure that out? Well, if we want degrees, typically, not always, now typically there is a pi in the radian. So if we want degrees, we would want to get rid of the pi, right? So we would divide by pi. So that's how I remember which way the fraction goes, 180 over pi or pi over 180. And if we want to get radians, we would want to have a pi. So we'd put the pi in the numerator on top. All right, so let's practice these. We're going to have a few things to practice. Let's go to our next page. First, we're going to convert. We're going to go, back and forth, either from degree to radian or radian to degree. So you can see with number 1, that is a degree. It's got this little degree symbol. So we want a radian, so we want the pi in the numerator. So we would multiply this out, and then we would reduce the fraction. And you will be able to use your calculator. So multiply it out, reduce the fraction, we should get pi over 4. Okay, let's try number 2. Same thing, we have a degree, we want to radian, multiply by pi over 180. This gives us, in reduced fraction form, 19 pi over 60. Okay, after we multiply that out. All right, now number 3 looks like a classic radian. Look, it's got a pi in it. There's no degree symbol by it, so we don't want the radians. We're going back and forth, right? We want a degree. So in this case, we'd multiply by 180 over pi. So the pi's cancel out, and I'm left with negative 120 degrees because now I'm in degrees. Now number 4 is a little bit of a strange one because it's a decimal. I mean, I don't see a pi there. And that's why I was mentioning a little bit earlier, you won't always see the pi in a radian, and that's okay. The special radians that we, on the unit circle that we have used before, they have pi's in them, but not all radians do. Just as a little aside, if we look back over here, we know pi is 3.14. Right? So if I didn't write that as pi and I wrote it as a decimal, it would be like 3.14, whatever, 17, whatever the rest of it is, 3.142 would be rounded to the thousandths. So 0.62 is a radian. How do I know? Because there's no degree symbol on it, which should tell you something pretty important. If you forget to put a little degree symbol on your degree, then it's going to be read as a radian. So just be cautious. So this is a radian measure. We don't want radians. We want to go to degrees. So we're going to put the pi in the denominator. Now, since we're already in decimals, then we would want to stay in decimals. And your calculator, you would put this in your calculator, and it would give you 35.523 degrees. So 0.62 radians would be around 35 degrees. And as we were looking before, if this is 3.12, it would make sense that 0.6 would be, somewhere over here in the first quadrant. So that should make sense that that's going to be 35 degrees, around 35 degrees. Okay, So then we're going to look at exact values, find the exact value of the function. All right, so here's where we go. We're going to look at this unit circle. Let me shrink this a little bit so we can look at these at the same time. So what would we do? We would find 4 pi over 3 on our unit circle. Okay, we see it right here. Here's 4 pi over 3. And then we want cosine of 4 pi over 3. Okay, so let's think about that for a second. Cosine of 4 pi over 3, what did cosine go with? Did it go with the x or the y? Yeah, cosine goes with the x. So I'm going to go to 4 pi over 3, and I'm going to write down the x coordinate at 4 pi over 3, which is -1/2. So my answer would be -1/2. Okay, we're just going to read it off the unit circle now. You know, later on, if I asked you what cosine of 4 pi over 3 is, you'd probably just be able to tell me. You'd be like, oh yeah, that's 1 -1/2. But that's, you know, after a lot of work with the unit circle. Now, if you notice, tangent is not on the unit circle. It's just sine and cosine. But let's remember, if you don't remember, there's a relationship. Tangent of theta is equivalent to sine of theta over cosine of theta. That's an identity, a trig identity. And that is like, we really equate it with sine, we're using as a y, right? That's equated with the y, and cosine is with the x. So when we find tangent of an angle measure, we want to do a fraction and find sine of 60 degrees over cosine of 60 degrees, and then we just simplify the fraction. All right, so let's find 60 degrees. It's right here. So it is the y value, which would be the sine value, which would be √3/2, over the x value, which is the cosine value, which is 1/2. Hopefully you remember how to fix a complex fraction. Remember, instead of dividing fractions, we would rather multiply them. Some people use the keep, flip, change, something like that. So you do √3/2 times, then we're going to flip the denominator to be 2/1. So it's actually √3. Tangent of 60 degrees is √3. Okay. Now let's do one a little bit more complicated, number 7. So we're actually going to use the unit circle. We're going to find 2 pi over 3. Okay, so let's move these marks right here. Let's look for 2 pi over 3. 2 pi over 3. So here it is right here. There's 2 pi over 3. So sine of 2 pi over 3, remember sine is the y value. Sine of 2 pi over 3 is √3/2. Okay, now we go to 5 pi over 6. These are being multiplied. 5 pi over 6 is right here. And we want cosine of 5 pi over 6, which would be -√3/2 minus. All right, now let's go to 2 pi over 3 again. 2 pi over 3 was here. We want cosine. So that's the x value. And then we want sine of 5 pi over 6. Sine is the y value. And now it's just a matter of, doing our arithmetic. √3 times √3 is 3. So this would be -3/4. Minus a minus would be plus. 1/2 times 1/2 is 1/4. And so let's see, -3/4 plus 1/4, that would be -2/4, which reduces to -1/2. Okay, so that's some exercises in using unit circle values. All right, let's look at this next concept, standard position. So an angle is in standard position if its initial side is along the positive x-axis, its vertex is at the origin, and its terminal side can be in any quadrant or quadrantal. Remember, we talked about quadrantals just a few minutes ago. Those are the axes, right? The x and y axis. Counterclockwise is positive and clockwise is negative. Okay, so those are just some things that we need to remember. So we're going to sketch the following angles in standard position. So I'm going to draw a coordinate plane. Okay. And I'm going to draw the angle in a different color so you can kind of see. So here's my initial side. We're at the origin this is my initial side right here. It's a positive 200 degrees, so we're going to be rotating counterclockwise. So that's 90 degrees, 180 degrees. So 200 degrees would be, you know, somewhere around right there. So we're going to show our rotation. So we rotated that way, and that would represent 200 degrees. And you could write 200 degrees here if you wanted to. Okay, so now let's sketch one, a different one. This is negative pi over 5. Let's think about this for a second. We saw up here pi over 6, right? This was pi over 6. So would pi over 5 be bigger or smaller than pi over 6? Pi over 5, is it bigger or smaller? Yeah, pi over 5 would be bigger, right? It will be a little bit bigger, just a little bit. So keep that in mind, but this is a negative rotation. All right, so let's draw our axes. And let's draw our initial side. Now we're going to go backwards. We're going to rotate. This is a negative angle measure. So pi over 5 would be maybe around right there. And so we're going to show that rotation that's backwards, and we can label it as negative pi over 5. And that is, those are examples of standard position. Now the next thing we're going to talk about is coterminal angles. Before I go over there and read the definition, let's think about this for a second. What is a coterminal angle? Basically, it's an angle that is in the same spot. So if I were to draw, let's look at this example right here. If I were to draw another angle that was actually right on top of it, but let's say got to it backwards. Okay, let's say I drew an angle but got there that way. Would that be called 200 degrees? It wouldn't, would it? What would it be? 200 degrees, if I'm going backwards, if I'm rotating backwards, this would be, so if I rotate all the way backwards, right, that would get me to here, that would get me to negative 180. I don't want that. I want to be right here. So what would that be? Right, negative 160 degrees. Those are called coterminal angles. They end up at the same place, but they get there a different way. Okay, so if that's a coterminal angle, they terminate at the same place. What do you think the difference in the measurements of two coterminal angles would be? Let's see, if we're in degrees, it would be 360 degrees. That would be the difference in their measurements. If we're in radians, it would be 2 pi, just depending on what unit or what measurement we're in. And our last example is looking at finding a positive and negative coterminal angle for each of the following. All right, so to get a positive coterminal angle, I'm just going to add 360. Okay, that will give me one. And that is 495 degrees. So that's a positive coterminal angle. Now let's get a negative one. So let's subtract 360. And that gives me negative 225. Okay, very good. Now let's work with radians. So if I add 2 pi to 3 pi over 4, I want to add 2 pi. But I can't add them unless they have a common denominator. So instead of adding 2 pi, I've got to add 8 pi over 4, right? Because 8 pi over 4 reduces to 2 pi, but now I've got the same denominator, so we can actually add those. So 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. So that's a positive coterminal angle. Now let's subtract 3 pi over 4 minus 8 pi over 4. And that would give me, what, negative 5 pi over 4. And that would be a negative coterminal angle. One other thing that I want to show you, we haven't talked about multiple rotations, but let me just give you an example. Let's say we wanted to draw in standard position, 400 degrees. Let's say we wanted to draw that. What would that look like? Okay, so 400 degrees, we start here, we go all the way around 90, 180, 270, 360. That's not enough, is it? I got to go a little bit further. So let's start with our initial side. Here's our vertex. We're going to rotate all the way around. We're going to rotate all the way around. That's 360. And we're going to go a little bit farther. And that would, let's draw our arrow. And this would be 400 degrees. So if there's more than one rotation, you just continue drawing the circles to show how you got to that location. And you're putting the angle on there so that you can show which way you rotated. All right. Okay.